Assalamualaikum warahmatullahi wabarakatuh, Madam. My name is Nur Atira binti Nur Karim Elhis Anwar. We are from Group C. Next.
My name is Razana binti Zakaria.
My name is Muhammad Khairi Ikhwan Benci Alwi.
So, Madam, I will start the presentation with the part 1, question number 1. Can Ikhwan show the coding and the table? Okay. For the question 1, it asks us to set the connection of LED in the breadboard as shown in the lab sheet. It asks us to write a program using STM32 F44CRE controller assembly language that will turn on LED D1, D2, D3 and then turn off those LED. So in the other words, all LED will turn on and off simultaneously. So first, we declare all the address that we use in this program. So first, RCC underscore AHB1ENR equal to 0x4002 3830. Second, GPIOB model equal to 0x4002 0400. And the third one is GPIOB underscore ODR equal to 0x4002 0414. Okay, next I will use table to explain the coding. Okay, first at table RCC underscore AHB1ENR, we only use GPIOB. So from the table we get the register 0x00000010, which is equal to 2. So at the program is at line 12. Next, for the GPIOB underscore model, for the output, there are two tables, which is first BIC and ORR table. So for the BIC table, the register we gain is 0x00 F00 F00. Where did we get that? From the model 9, 8, 5 and 4. From that model, we substitute with value 1, 1. At the table ORR, the register we gain is 0x000505000. For the ORR table, we substitute the model 8, 9, 5 and 4 with the value 0, 1. So in the STM, we can see it at line 17 and line 19. Okay, next for the GPIOB underscore ODR. At GPIOB underscore ODR, we use condition. So first condition is condition 1, LED 1, D2, D3 will on at active flow. So from this, the condition 1, we gain the register 0x0000 FECF. Why? Because we substitute the value of 0 at ODR 4, 5, 8 and 9. So at the condition 2, LED 4 is off, also at active flow. So we gain the value is 0x000 FF. So all the ODR is substituted with 1. So at the STM, first condition is at line 24 and the second condition is at line 30. Also in this program, we use delay label to delay millisecond in R0 and label 1 to loop the program forever. And here is the result of the lab 2, part 1, question number 1. So from this circuit, we connect PB4 to LED D1, PB5 to LED D2, PB8 to the LED D3, PB9 to the LED D4. So in this question, so when we apply the first condition, LED D1, D2 and D3 will on, and when the condition 2 is applied, all the LED will turn off. So here is the result of this lab section. So for next question, I will pass it to Razana.
So for part 1, question 3, for the RCC, AHB1, IENR, and GPIOB model is the same as question 1. But the only GPIOB ODR is going to change. So this question wants us to make the LED from D1 to D4 turn on one by one. So for the first condition, LED D1 is on. So the circuit is active low. To turn on the LED, we declare 0 at ODR4 because D1 is at ODR4. Next, so the register will be 0 X0000FFEF. For the second condition, LED D2 is on. So this circuit is active low. To turn on the LED, declare 0 at ODR5 because D2 is at ODR5. Next, so the register will be 0 X000FFDF. For the third condition, LED D3 is on, so the circuit as usual is active low. To turn on the LED, we declare 0 at ODR8 because D3 is at ODR8. So the resistor will be 0 at 0000FEFF. For the fourth condition, LED D4 is on, active low. To turn on the LED, we declare 0 at ODR9. So because D4, it's at PV9. So the register will be 0 at 0000FDFF. So the result for part 1, after we modify the model for output, this is the coding for part modify. And after we run it, we can see that LED D1, D2, D3, and D4 turn on one by one, and it will be looping forever. So next, I'll pass to Muhammad Hairul Ikhwan for the next question.
Okay, next for the part 2, the question want us to show set connection LED and the switch. So we can see that there is an input and the output. Output is LED and the input is switch. First, the question 1, when the switch 1 is pressed, LED 1, 2, and 3 will be blink, all on and all off. Next, when the S2 will be pressed, LED 1 until 4 will be on one by one. And then last, for the default condition, there is no push button press, all LED is off. So as usual, we do the table of RECC AHB1ANR. First, we on the output. First, we on the input. Input is at GPIOA, so put 1 at GPIOA. So it will become 0 at 00000001. And next for output, output is at GPIOB, so put 1 at GPIOB. So it will be RCC AHB1 ANR is equal to 0x00000010. So after we declare the AHB1 ENR, so we put it at the coding. So for first, for the I, GPIOA, so we put 1, and then GPIOB, we put S2. So next for the model, we set model for output first. So when model has the output, so it will be has BIC and ORR. So for BIC, we put 1 1 at model 4, 5, and 6. So it will be a 4, 5, 8, and 9. So it will be 0x000F0F00. Next for ORR, we put 0, 1 at model 4, 5, 8, and 9. And it will become 0x00050,500. and we put it in the coding at the output model. So at here for BIC and at here is for ORR. So next we declare model for input. So input is only has BIC. So we put 1 at the model at the BIC model 1 and 4 to turn on the switch at 1 and 4. So for input model input we can get 0x000003 So next for IDR for the input, so we do the masking process to force or the disconnect device to be 0 and 1 for the connected device. So for the input there is only PA1 and PA4. So we put 1 at the IDR1 and IDR4. So it will be 0 at 00000012. So we put in here after we do the masking process at here. And next, for the first condition, we push switch 1. So the circuit is at active low. So we put 1 at the IDR4 to turn on the switch 1. So all of the number will be 0 because of the masking process. So condition 1 will be 0 at 00000010. And next for condition 2, we put as switch 2 on. So we put at IDR1 is 1 and then the other is 0. So it will be 0 at 00000002 for this and this. So next for the last condition is switch 1 and 2 off. So we put same as the IDR at first after masking process. Next for ODR condition 1, LED 123 is on. So it at active low. So we put 0 at 4, 5, 8 and 9. So it will be FECF. So we put at coding ODR at first. And next LED LED is off. So we'll put all 1 and it will be FFFF at here. All LED is off. And next for the third condition, LED D1 on. 3, 4, 5 and 6 is LED D1, D2, D3 and D4 on one by one. So at here we put first D1 on, D2 on, D3 on and D4 on until D4. Same as question part 1, but we do this using a switch input. And next, last for the ODR, kita we turn off the ODR, turn off the LED if the switch doesn't push. And next we declare the delay millisecond in RO. So 5325 DLI subs until end. Okay, next for the result, lab 2 for part 2, as we can see, there is a input S1 and S2. So first, if we push S1, so it will on the D1, D2 and D3. And next, if we push S2, it will on D1, D2, D3 and D4 one by one. And next, last, if we doesn't push and button, so it will turn off all LED. So let we run this coding. later we run the coding. So as you can see, the LED will be all of LED doesn't on. So if we push first button, so it will on D1, D2, and D3 for switch 1. So for the second switch, if we push the second switch, it will be on one by one, D1 until D4. So if we doesn't push any button, the LED, the all of LED is turned off. So that's all from us. Thank you.